Okay, I did not finish the last lecture, so I'll continue do some problems from the last section. So we're going to find the absolute value or absolute minimum value of function. Okay, define unclosed bounded domain. It's very similar to the problem in calculus 1. You know, if you're given a function, define a closed interval, how to find the maximum value, absolute maximum value. You don't need to understand the graph of the function. You just need to find the critical numbers and then evaluate the function at the endpoints at the critical numbers, okay? Then choose the largest one, smallest one. That gives you the maximum, absolute maximum value, absolute minimum value. Now, for function, define a closed bounded domain in the XY plane. You do the same way, but this time the endpoints will be the boundary of the domain. That's it. Okay. So the function is going to be continuous. Let's take a look at problem number 32 from the book. Okay. So we're going to find absolute value of the function. This is going to be x plus y minus x times y. Okay. And the D is closed, means including the boundary, closed triangular region determined by the following vertices 2 and 0 and 0 and 0, 2 and 0 and 0 and 2 and 4 and 0. Okay, find the absolute maximal and minimal values, okay, over that closed interval. Yeah, x plus y minus times y is 0, 0, 0, 2, 4 and 0. Okay. So let's draw the triangle. This is a 0. And 0 and 2, where's the 0 and 2? It's here. And the 4 and 0 is here. So we have to draw a triangle. Okay, just sketch the graph. So this is a closed interval. It includes the boundary. Okay, it's like a closed interval. This is a closed region. Sorry, closed region. So in order to find absolute maximum value, that's two possibilities. The function attains the absolute maximum value inside the triangle, right? And that point must be a critical point. Okay, partial derivative should be 0, or on the boundary. Now boundary is a triangle, so a little bit more complicated. Then you have to look at the values of function around the boundary and at the critical points inside. So first of all, you have to find the critical point. Step 1, right? Find the critical point. So you find the partial derivative, right? Partial derivative, and then the partial derivative y with respect to y is going to be 1 minus x. So you set that to be 0. Let's see if we can get the critical numbers inside inside the triangle. I think I got x and y. This is called the critical point, not a number here. Is it in the triangle? Maybe. Now, what is the equation for this line? The equation for this line passing through those 2 points, it's going to be you can figure it out, right? The equation for the line. You know, how can I find it? Right, the slope, right? The slope is going to be the difference of the y coordinates. Wait a minute, what I got here? 0, 2, yeah, not 0, 2, 0. Right? So the difference of the y coordinates, so it's -1/2, right? And the equation, that's I'm going to figure out the equation for the line passing through those 2 points. So y minus 2 equals -1/2 times x minus 0. So you get y minus 2 equals -1/2 of x. You can also multiply both sides by 2. So 2y minus 4 equals -x. Or you can also express in the form like that. Okay? So this is the equation describe that line. Okay? So how can I check whether the point 1, 1 will be inside the triangle? Well, the origin, okay? At the origin, 0 and 0, 0 plus 2 times 0 equals 0, which is less than 4. So at the point where the 1 plus 2 times 1 is going to 3, it's less than 4. So those 2 points on the same side of the line. So that means it is in the triangle. Okay. So this indicates this is inside the triangle. Okay. Right. So the next step is how can I find how can I look at the value of the function around the boundary? Maybe the boundary is easy. It's easy to check. Okay. So I have to find the maximum value. So the absolute maximum value of the function is going to be the largest value of f, 1 and the 1, and the maximum value of f along the boundary. So I think I have to find the, not only just find the value at the point, I needed to find the value along the boundary, but the boundary is maybe it's easy to find out. So x plus y minus x times y, so it's 1. Okay, we just only know this one. So along the boundary, there's 3 sides there. Okay, along the boundary, there's 3 sides there. How can I describe these 3 sides? Let's go back to the triangle, right? Here's a form, here's 2, here's 0. So along the bottom side, x should be called t. T is between 0 and 4, right? I use a parameter. Okay, y equals 0. Okay, so then f of t0 is going to be t plus 0 minus t times 0. It's just t. So it's clearly the maximum value, minimum value, it's clear there, right? So the function, the largest possible value is 4, the smaller possible value is 0. Okay, that's it, right? Along this line. That's the first part. The second part, and the y-axis part. So x is going to be 0, y is going to be t, but the t is between 0 and 2. Okay, so along that, the value of the function is also easy to calculate. So 0 plus t minus 0 times t, which is t. So t is between 0 and 2. Okay, f of 0 and t is between 2 and 0. So the smallest value is still 0, the largest possible value is 2. The difficult part is the other side. Okay, how can I describe the other side? I go back to the equation. I think I needed to let y to be t, then x will be 4 minus 2t, okay? So you can parameter x is going to be 4 minus 2t, y is going to be t, okay? Then you have to figure out what is the largest value for t. The smallest value for t is going to be 0, okay? When t equals 0, x is going to be 4, y 0. When t equals 2, X is 0, Y 0. So T is between 0 and 2. Okay. Right. So now let's estimate the value. It's going to be 4 minus 2T and the T, right? X plus Y minus X times Y. Right? So this is X times Y. So X times Y, 4 minus 2T times T. Whoa, this is going to be a quadratic equation. So let's look at this. 4 minus T here, minus 4T plus 2T squared. Right? Multiply this out. Okay. So I get the quadratic equation. It's not too bad. We know how to deal with the quadratic equation, right? So this equation is a quadratic equation. Now we have to find the minimum value, maximum value on the interval from 0 to t. Right? Okay. So how do I do that? Well, if this is denoted by ht, you just need to solve another maximum value problem, right? Okay. So the maximum value is that you find the critical number. It's a 4t minus 5. Let's be 0. T is going to be 5 or 4, right? It's also a critical number. So the maximum value, the minimum values, and you have to look at the end point, and then the critical point. Okay, it's going to be 2 times 5 over 4 squared minus 5 times 5 over 4 plus 4. Now this is a little bit difficult to compute. I think we still can do that. 4 16, so it's 8, 5 squared, and 4. Okay, plus 4. Let's do it. So you can take a 4 square out. 1 of 8 minus 1/4 is going to be negative. Okay. So I'm going to get, I don't have a calculator, okay. 32 minus 25. Okay, 32 minus 25 is going to be 7, right? 7 over, yeah, 7, 25 plus 7, 38. Okay, so it's anyway, it's a number smaller than 1. Then finally, you have to look at this value. It's 2 times 2 squared minus 5 times 2 plus 4. So 8 plus 4, 12. 12 minus 10 is 2. So you have 3 values. And clearly, this is the smallest value. Okay, this will be the largest value. Okay, so the smallest value along this diagonal, okay, the smallest value is going to be 7 over 8. The largest value is going to be 4. Okay, and then on the whole domain, the triangular domain, what is the largest possible value? Let's go back to here, right? The largest possible value, okay, already did a, okay, this is a critical number. It's not good. It's 1. Okay, I think a 4 is the largest possible value. So the absolute maximum value is going to be of f on the d, okay, is going to be 4, okay, and it occurs at one of the endpoints, a corner vertex, okay. You can even figure out where it is when t equals 0. When t equals 0, when t equals 0, x is 4, right? So at that point, right, you can tell that. So the absolute minimum value is not at the critical point inside the triangle because that gives you value 1. And actually, the minimum value is going to be, it's not on the other side of the triangle. Okay, even 7/8 is the minimum value of the function restricted to the side, but that's not the smallest value for the function on the domain. I think the smallest value is 0. So on D is going to be 0 at the origin. Right. That's it. So this will be the complete argument. Very similar, but to the maximum value problem on the function in one variable. But now the endpoints here is going to be the boundary of the function. Okay. Well, the next problem, this section 14.8 is called Lagrangian Multipliers. I don't have a time to go through the argument and show you why this is true, but what we're trying to do is we are given a function of one, we are given a function of one variable or two variables, and we're trying to, then it's restricted to another condition, okay, restricted. So a function can be defined on the domain, okay, on the domain, but we want to find the maximum value because look at that. We want to find the maximum value along the strict line, for example, right? So how do you solve the problem quickly? You can just focus on the function along some a line or surface, but there's also an easy way to do. So let me state the theorem. In order to find the maximum value, let's consider function in three-dimensional space. In order to in order to find the maximum values of the function, subject to the constraint, right? Then all you needed to do is just solve a couple of equations, right? So this is the idea. You can, so to find the maximum or minimum value of the function, okay? This function, for example, you have three variables, okay? But this will be subjected to the condition g of x, y, z equals k. Then you just needed to do the following. The first step, you consider, find all x and y, okay, such that n the lambda. So this is a necessary condition. If the function attains the maximum value or minimum value at some point, subject to this constraint, then at this point, you must have the following. This is like a critical, generalized critical numbers, okay? It's in lambda, the gradient, okay? The second, of course, this still satisfies this condition, okay? Then you evaluate the function at those points. Find at this point, okay? And then you find out the largest one would be the maximum value, and the smallest one is the minimum value, okay? So this is the idea. So let me draw the picture here. The function is defined on D, right? So F, this is a three-dimensional space. It's two dimensions, easy to draw the picture. So you want to find the maximum value. Yeah, but restricted to this is a g, x, y, z equals k. You want to restrict the function f to the set determined by this k, right? To the set determined by this k. And then you just need to find a bunch of those points on this set. And at those points, this equation should hold. Okay, that's it. It's very simple. Now, our condition, so there's a condition here where make sure we have to assume that this is not going to be 0 along that line. Otherwise, we have troubles, okay? We're not going to solve the problem. So this is kind of like a generalized critical point. You see that, right? If the function is defined on the domain, if I want to find the local maximum point, local maximum value, local minimum value, or even absolute maximum, absolute minimum value, what I'm going to do is I just find the critical numbers, critical points. Then you look at the values of the function at this critical points. Okay. Then also have to look at the end points. Right now, I have the set determined by g of x, y, z equals k. So this is already it's a low-dimensional set. Okay, if the function defines three-dimensional space, usually give a surface. So if the function restricts the surface, then it must have a maximum value, a minimum value. And then all you have to do is just find the generalized critical point on the surface. How to determine it? You have to use the above equations. Okay, there is a proof in the book before that method mentioned. Okay, but I'm not going to go through that. So let's look at some problems. For example, a typical problem is this is a two-dimensional. Okay, it's going to be 3x plus y. Okay, find the maximum value and minimal value of the function restricted to the set, to the circle, right? To the restricted to the circle, but that circle is determined by x squared plus y squared equals 10. Okay, so x and y are not arbitrary. Otherwise, the function itself is a linear function. It is defined on the whole plane. Okay, it does not have a maximum value, does not have a minimum value. It's going all the way to positive infinity, all the way to negative infinity. Now it is restricted to the circle. Right? This is a circle. So how do you solve the problem? You can solve the problem in two different ways. You just only consider the function on the circle. You can parameterize the circle, right? The circle can be, it's a square root 10 cosine t, y equals square root t sine t, right? T is between, you can use the end point between 0 and 2 pi. Then the function becomes a function for one variable. Okay, then you just need to find the maximum value, right? Because it's restricted to the circle. The function is becomes a function for one variable. Then it's easy to find out, right? You can, what is the maximum value, what is the minimum value of this function along the circle. This becomes a function for one variable. So you can use a calculus one idea, find it, right? You can find let's call it I'm not going to, this is denoted by h of t. You just need to find the maximum value, minimum value. So let me check, So the derivative would be negative 3 square root 10 sine t plus square root 10 cosine t equals 0, right? So, so what you get here, you get the equation, let's say tangent t equals 1/3, right? Tangent t equals 1/3, okay? Now, what is sine t over cosine t equals 1/3? So if you look at the t, right? This is angle t actually, right? So tangent equal 1/3, you only have two ways of both are positive or both are negative. I think of these two angles. Okay. So what value gives you tangent t equals 1/3? Okay. T is working. You cannot figure it out, right? No. Okay. So you don't know the value, right? T, but at least you can say t is going to be arc. Okay. Arctangent 1/3, right? But arctangent 1/3, I think you can even find the sine t and cosine t, because that's all you needed to know the maximum, right? So t is going to be that, and another one is a pi plus. I'm not going to explain to you why you get two. You know you have two solutions. The question is how do you express them? Arctangent 1/3 only gives the angle between 0 and pi over 2. In order to get the other one, you have to add the pi to that. Okay, but that's not what I need. I need is actually a sine t, cosine t, right? The value. Both sine t, cosine, both are positive, both are negative. If you look at the triangle, this is the t. Tangent is 1, 3, right? And this side is going to be what? It's going to be square root 10. Right? So sine t is going to be 1 over square root 10. Cosine t equals 3 over square root 10. That's one of the solutions. Another solution is both are going to be negative. Okay? Both could be negative. So this is the first solution. That's a t1. And t2, sine t2 equals negative. That's in the third quadrant, okay? All right, so let's evaluate ht1. Where's ht1? ht1 is going to be 3 square, yeah. So I'm going to take the square root. Okay, 3 square root cosine t1, okay? 3 square root 10 plus sine t1. All right, so it's going to be canceled out. It's going to be 10. All right, at another critical point, this is going to be negative 3 over square root 10. Right, so it's going to be negative 10. So those are probably the largest possible minimum value, because at the end of point, don't worry about it. At the end of point, 3 times cosine 0 is cosine 0 is going to be 1. Right? It's going to be 3 square root 10. Then at the end of point, it's just 2 pi. It's the same value. So this is not going to be the maximum value, minimum value. So the function f restrict to the circle. The largest possible value is 10. The smallest possible value is going to be negative 10. Okay? So the maximum value of f on the circle is going to be 10. Okay? And the minimum value is going to be negative 10. So you can use use the idea from calculus 1 to solve the problem. No question about it. Just needed to express a function as one variable. So what I'm trying to do here, it's one example is enough. I'm trying to look at the two functions, right? The one is, yeah, let's go back to this. F of x is going to be 3x plus y. Now g of x is going to be x squared plus y squared, because the circle is g of x, g of xy equals 10, right? So I needed to look at the gradient of f. It's going to be partial derivatives. That's a 3, then it's 1. Great. Because the gradient of g of x is going to be 2x is 2y. Okay? This partial derivative of the function with respect to x and with respect to y. So what you have to do is you have to find those points along the circle such that gradient of f is going to be the gradient of f is going to be lambda times 2x 2y, and then g of xy should be square equal to 10. So x squared plus y squared equals 10. Okay? So whatever your solution is going to get is going to be the point on the circle. Right? So this is a point on the circle. Okay. So how do you do that? Well, clearly lambda 1 cannot be 0, right? The first equation, because if it's 0, then the left-hand side is a 0 vector. It's impossible. So clearly lambda is not going to be 0. So x is going to be 3 over 2 lambda by the first equation. Y is going to be 1 over 2 lambda. Then you plug into the second equation, you will get 3 over 2 lambda squared. You get 10. Okay. So let's solve it. I think it's easy to get, right? So what you get is 9 squared is 10, 4 lambda squared equals 10. So I'm going to get lambda squared is going to be 1 over quarter. Okay? So lambda is going to be plus minus 1/2. Great. So you get the lambda, then you can get x. So x is going to be 3 over 2 lambda. So it's going to be plus minus 3. Y is going to be plus minus 1. So you got 2 points. Okay? You got 2 points. If it's on the circle, what are those 2 points? X is 3, y is 1. So it's going to be 3 and 1. Negative 3, negative 1. Okay, those are the 2 points. And this is what we get here, T1, T2 in the first. When we try to use the function of ht, right? H of t, then this is the corresponding point. All right. So the value of the function 3 and 1 is going to 3 times 3 plus 1. It's going to be 10. Okay, this is absolute maximum value. And f negative 3, negative 1 is going to be 3, negative 1 minus 1 is negative 10. So the minimum value of the function. I think it's much better way. I don't need to deal with sine, cosine. So you get this. Okay. You just need to find the 2 points. Those are critical points. We call it relative critical points. Okay. On the set, okay, determined by this constraint. Right? So let's take a look at a 3-dimensional problem. So let's look at problem number 8, 6, 10. I try number 10, okay? So we have 3 variables. So natural log of x squared plus 1, natural log of y squared plus 1, plus natural log of z squared plus 1, right? And yeah, find the maximum value and minimum value of this function, of the function on this on the surface, which is determined by x squared plus y squared plus z squared equals 12. Okay. So now you have to use this method to solve, because restrict to this sphere. This is sphere. Then you still, you can write the function in terms of two variables after it's restricted to sphere. But this is very complicated. Okay, you can parameterize the sphere by by parametric equations, but I don't think it's a good idea. So we have to, what we have to do is, let's draw the graph. The function is defined on the whole region, in the whole space. Every point, the function has a value. But we are going to only consider the value of the function on this sphere, okay, with radius of square root 12. So how can I find the maximum value? We just need to find the critical point on the sphere, basically, okay? Those are the only candidates. Suppose the function, what the theorem says that if the function reaches the maximum value at some point, or here or there, and those points must be a relative critical points, okay? So you just need to find those candidates and evaluate the function at those points, then you find the absolute maximum value, okay? All right, so let's do this problem, okay? What I'm going to do is I'm going to find the gradient of f. So I have to find out what is, I have to let g of x, y, z to be x squared plus y squared plus z squared, okay? Then I can start to do that. So gradient of ff is going to be, now, I usually have to put x, y, z here. So when I find the partial derivative of f with respect to x, only the first term still there, right? So it's going to be 1 over x squared plus 1, and the differential 2x, differential x squared plus 1 is 2x. So this is a gradient of the function, right? So gradient of g is also going to be simple. It's 2y and 2z, okay? So now, how do I determine the candidates at which the function has a maximum value? I just needed to look at the function, look at this equation, okay? So this equation is going to be 2x, x squared plus 1, 2y, y squared plus 1, 2z, z squared plus 1 equals lambda, 2x, 2y, 2z. And here I still have to say x squared plus y squared plus z squared equals 12. Well, actually what you get is 4 equations, 4 variables, x, y, z, lambda, okay? But lambda is just a parameter. We don't need it exactly, okay? But we have to find lambda first. So take a look at this. I can write down the 4 equations. A little bit difficult, right? I think lambda cannot be 0. Right? Lambda cannot be 0. Otherwise, x, y, z will be 0, then the second equation is not valid. It's valid. Okay. So let's see what we can get. And x squared plus y squared plus z squared equals 12. Right. So how do I solve this? Well, you can say I can cancel x, but what happens if x is 0? Right? It's possible x can be 0. Okay? Yeah. How do we solve this? Now, first of all, lambda cannot be 0, right? Clearly. If lambda is 0, x, y, z are 0, then the last equation is not satisfied. We can determine the value of lambda. Yeah, lambda is not going to be 0, then we can. So there are a couple ways to do, lambda. If x is not going to be 0, x can be canceled out, right? Then x is determined by, you can determine the x squared plus 1. Then you add them together, you will get the value of the lambda. Okay, once you get the lambda value of lambda, you can get x. So you have to start somewhere, right? So that's just part. Let's see, how can we get the value of lambda first? Okay, in order to get the value of the lambda, so we assume, okay, let's assume, okay, that's maybe that possible. There are many solutions here. So we can if any of this equation, if x is 0 or y is 0, that equation becomes trivial because both sides equal 0. Okay, right? So x squared plus y squared z squared is going to 12. That means at least one of them is not going to be 0. Okay, so we may assume x is not going to be 0. Okay, if x is not going to be 0, then lambda is going to be 1 over x plus 1. Right? So x squared plus 1 is going to be 1 over lambda. Right? Similarly, yeah, let's do the first case. They're all not equal. Then no of them is 0 because that's easy. Okay. Then you find out lambda is also equal to y squared plus 1, right? Then y squared plus 1 equals lambda. So x, y, z, they're all the same. Right? Lambda equals z squared plus 1, so z squared plus 1 equals lambda. Okay. So I have to find the value of the lambda first. So I add them together, I get x squared plus y squared plus z squared plus 3 equals 3 over lambda, right? And because x squared plus y squared plus z squared already is now 12. Then this implies lambda equal 1 over 5. Right? Lambda is going to be 1 over 5 because of 15 divided by 3 is 5. And yeah, that gives a value. So in other words, x squared equals 1 over 5 minus 1. It's impossible, right? Yeah, it's impossible. It's negative, so impossible. Yeah, let's double check carefully. Okay, so we have those equations, right? If x, y, z are not equal to 0, if x, y, z are not equal to 0, then no, hold on. Yeah, so I know it's going to be 15 equals 3 over lambda, but lambda is going to be 1/5. Oh, yeah, that's right. So this is my mistake. It's possible. Yes, you're right. So 1 over lambda is going to be 5. 5 minus 1 is going to be 4. Okay? So they are all equal to 4. Okay. So now, how many points you're going to, how many solutions you're going to get here? You're going to get, x equals plus minus 2, y equals plus minus 2, z equals plus minus 2. You have so many points. So 2 times 2 times 2, 8 possible solutions. 8 possible solutions. Okay, the 8 possible solutions. Around the sphere, there are how many? If you over the sphere, right? 2, 2, 2 is 1 point, and total there were 8 regions. Okay, away from. So those are the 8 points. So now the next problem is you assume one of them, as a 2 are not going to be 0. One of them is 0. Can we get solutions? Okay. So we assume that x equals 0, y is not equal to 0, z is not going to be 0. Okay. Yeah, you have to do that. Okay. When you get this solution, you can, there are x, y, z are in the equal position, so we can. Then you go back to the equation. The first equation is trivial. I don't need to worry about that. Then the second equation, lambda is going to be y squared plus 1, right? That implies y squared equals 1 over lambda minus. Yeah, hold on. Yes. Okay. So this is also z squared plus 1 implies z squared equals 1. But when you add them together, since x squared is, x squared plus y squared plus z squared, right, is going to be 12. But now this time you only have 2 there. Okay. So what you get here is to have a solution, unfortunately. Okay. 14 equals this, lambda equals 1 over 7. Too bad. Okay. Then you can put it back here. So y squared equals 7 minus 1, which is 6. Z squared equals also 7 minus 1, which is 6. Then you have y equals plus minus square of 6. Z equals plus minus square of 6. Whoa. We get too many points. Okay, we do have lots of solutions, unfortunately. So we get x equals 0, but then x, y, z are in the equal position. You can, y could be 0, x could be plus minus square root of 6, okay? And then z could be plus minus square root of 6, okay? It's too bad, yeah. So x, another set of solutions plus minus 6, so y equals 0, z equals plus minus square root of 6, okay? And then x equals plus minus 6, y equals plus minus square root of 6, and z equals 0. Okay, too many. Let's go back there. Whew. I'm surprised. Yeah, those are the solutions. Yes, I'm pretty too many. Okay, then I get x equals 0, y equals 0, z is not going to be 0. Okay, in that case, only when 2 over z squared plus 1 equals 2 over lambda, right? So that means lambda is going to be lambda. No, it's 2 over lambda. So lambda is in the denominator, not. No. Lambda is on the top here. Okay. So this is just 2 lambda. So implies it implies that z squared plus 1 equals 1 lambda. So it's 1 over lambda minus 1. All right. That's still okay. You know, when you get the equation x squared plus y squared plus z squared, which is 12, that is going to be, that's one side, it's going to be 0 plus 0. So that implies 13, right? So x squared plus y squared plus z squared is going to be just 1 over lambda minus 1, okay? But this is supposed to be 12, right? It's slightly different from the above. You see that 2, right? So it's 12. So it's going to be 13. So lambda equals 1 over 13. Okay? Lambda equals 1 over 13. Then z square is 12. The square of 12. Okay? So that means you can also have the solutions x equals 0, y equals 0, z equals plus minus. Then x equals plus minus square 12, y equals 0, z equals 0, and x equals 0, y equals plus minus square 12, and z equals 0. Okay. Oh, I have too many points, but some points easy to check. Okay, we are looking at the value of the function. Okay, the value of the function. The value of the function. Let's look at value of the function at those points. So we are going to, what I'm going to do is I'm going to have 3 groups, right? And this is called 2. Where's the first one? That's the first group of points. Because the sign really doesn't matter, okay? This is group 3, okay? So for the group 1, okay, it's going to be 2, 2, x, y, z are 2, 2, 2, right? X, y, z are 2, 2, 2. So it's going to be natural log of 2 squared plus 1, and that's a 5. Natural log of 5, natural log of 5, it's going to be 3 natural log of 5. So I think it's still easy to compute it. And at the points in group 2, and x squared is going to be what? Group 2, x squared, y squared are going to be 6, 6, okay? So it's natural log of 7 plus natural log of 7, as always 0. So 2 natural log of 7. For points in group 3, only one variable is going to be square root of 12. So x, y, z is going to be natural log of square root of 12. That's just 12. 12 and 12 plus 1, 13. Okay? So the other 2 are being 0, you know. So the value is still easy to evaluate. So which number is larger? I don't know. It's harder to compare, right? So if you really don't know, don't have a calculator, you can say that the maximum value of f on the sphere, okay, is going to be the maximum value along these numbers, okay? Otherwise, you can do rough estimate if you have a time, but don't use a calculator to estimate. That's cheating. You immediately indicate you're cheating. You put the numbers there, decimal numbers there. Okay, don't be too smart. Okay, you don't need to give me extra information. Very few students are able to memorize those decimal numbers. Yeah, when we're grading a quiz or test, I find out some students put decimal points on some like a radical of 13. And I say, how can you remember that? I say, I did. If you did the homework, you memorize. I don't believe that you don't have a super memory. So you must, look at it someplace. Okay. So yeah, you can just simply write like this: the maximum value of the function on the sphere is going to be it's going to be this. Okay. And then the minimum value of the function on the sphere is going to be the minimum value of the smallest value of this. Okay, I think I can figure it out which number is a smaller, which number is larger. I'm pretty sure the natural log of 13 is the smallest value, and 3 times natural log of 5, that probably is the largest value. Okay. Yeah. So that's all about today's class, and we're going to take